This is the first day panel. If you have these before, it's basically a free discussion time where we talk about where we want to take this framework. Let's say where we'll be in the next 5 years. Any ideas or questions about how we can stay relevant and we can continue to meet the needs of developers. Maybe new features we need to implement, maybe annoyances we need to fix. So of course.
Adam? I guess kicking it off with the binary data question is there a way to make the binary API friendlier, or what would need to be done there to make it work nicely with, say, Arrow and DuckDB?
I think Kyle can probably tell us a wish list of things. I'll start from what I think. Right now, the way you tell a layer to use binary data is you send it an object to the data prop that has a nested attribute field that has a bunch of nested accessors to either a typed array or WebGL buffer. It is also with v9 even harder to create that buffer yourself. I think without breaking things in the v9 timeframe, what we could do is to promote that to a more top level API. For example, right now, to pass to the attributes for a scatter plot layer, you say data.attribute.get fill color accessor. We could support that on top level. You just pass that accessor to the get fill color prop. We don't have any API pattern that's conflicting with that right now, and we can even make some tweaks to what that object is to make it a little easier to pass on. There are things like when you're leaving binary blocks, it is not easy for multiple buffers to share, multiple attributes to share the same buffer unless you create that buffer yourself outside of the layer. We've had a bunch of experiments in the past about this to create a global addressing of that data object, and my address is here, but not documented on purpose because I'm not sure if that was the right thing to do. That was something initially put in there for a PyDAC experiment. I think Longboard has done a much better job in terms of creating a more desirable interface for the Python. And I think we should definitely learn about that to see what kind of API would do that interfacing with Python. More intuitive to do.
I would, I mean, it's a problem I think a lot about, and one of the ways to look at it, let's say that we wanted to put in built-in or native support for Arrow data into vis.gl, so that you basically load your Arrow through some means via gPocket to Arrow directly as Arrow, or just build your Arrow table using the Apache JS API. Now, wouldn't it be wonderful if that Arrow table that you have now, you could pass it into the data prop vis.gl and it would work. And there's some problems with that because the the data that you're loading that's in the arrow table, it's going to be binary and columnar. So that's beautiful. Obviously, you can upload binary columnar data to the GPU. But the structure of that data, I mean, talking about arrow here, not even geo arrow. You know, you could have columns with longitudes and latitudes, and they could be two separate columns. But today, vis.gl expects the position attributes to be XYZ, XYZ laid out. So not interleaved in typical meaning, but you know, the kind of coordinates are successive. It doesn't expect three different attributes, one with X and one with Y and one with Z. And you know, there could be many variations of that where you have binary data, but it's not quite in the right structure. There's at least two ways we could deal with that. And one is we could have a set of transformations so that we could pre-transform that data, perhaps in compute shaders. So you upload it into the GPU in the columnar format it comes, and then we just provide some way for you to say that, okay, positions are going to be column X, comma, column Y, comma, column Z, and then we, you know, repackage them. Or we could even make the shaders more dynamic. So we could allow the shaders to, the attributes in the shaders to vary to match the structure of the data. So I think it's on that level where you can just put in you know, an arrow table, arbitrary format, find just a very little description of how it's going to be interpreted, and just have it. It would be really beautiful. So this is something we have like a binary working group, and we need to really get started, hash out, and make sure we dream the same dreams about how we're going to.
I just want to add that it's been, you know, since, I don't know, since when we were still at Uber, we were talking about, you know, can we have some API that so shuffling and stacking. And the answer was always, yes, we can, but how do we do it? What kind of API are we going to expose to the user? Anything we choose will feel really arbitrary. And what I'm really personally really excited about Arrow is that it provides us this standard format that every other package, every other platform language are all adopting, and don't have to come up or make up our own thing anymore. And that making that choice really easy.
I mean, one interesting aspect of it, just technically, is you have this arrow table on the CPU. Now we need to duplicate it onto the GPU. So what you want in a way is kind of a class that parallels, you know, the CPU side arrow class, like a, you know, a GPU. So if you have an arrow table or a GPU table, you should be able to. So if you imagine that imagine creating a library where you have a function that says make GPU table, and it takes an arrow table, then it uploads all the columns into buffers on the GPU, and now you have an object with the similar operations. Then we could create all these, you know, operations on the GPU. We could create things like entering the table, aggregating the table, you know, basically table processing SQL style operations, but they could be implemented on the GPU, and now you could make them composable. Each of them would take a GPU table as an input, some parameters, and spit out a new GPU table, which would be probably contain many of the same columns, maybe some of the columns replaced, just like Arrow works. And so then you can imagine the power of being able to, just in this composable modular spirit of the vis.gl framework, that now you have independent table processing, binary columnar table processing library that could be maybe even on the Luma.gl level, you know, independent of DEC. You can use for many use cases. And in the end, that GPU table is then something that DEC can accept directly in layers. And so I think we could provide a lot of power to programmers, not just make it easy to put your Arrow data into a layer, but actually build real GPU, composable GPU capability.
Just to add to that, I also think we have quite an interesting situation here, thanks to Kyle on Longboard. Even though vis.gl isn't supporting Arrow at the moment, then some of the issues that have come up trying to integrate Longboard with vis.gl kind of demonstrate what are going to be the problems we might have if we switch to having Arrow as a first-class citizen. So one of them is this question that kind of started on this earlier about how do you apply a color map? Having this idea of callback function is not really working so well if you want to pass attributes from the outside. So maybe it'd be worth thinking of other ways that we could implement these accessors that are more friendly to this approach. For example, we could have like a lookup table for doing that, doing it on the GPU, and then it doesn't matter so much what is your interchange format from in Python all the way in JavaScript now to the GPU.
Yeah, my comment was going towards actually what you were just describing there. I'm not so sure about that paradigm. I think in part one of the things that maybe we should also consider is like what is our position in a broader ecosystem. There's a very clear Kali project that is winning a lot of attention. We all know is DuckDB. Is right now, and a lot of people are asking for more. Are going to be asking us for more and more on DuckDB support. And there's already projects like Mosaic coming out of I'll find it from this research institute in US, that they are already kind of like using DuckDB as the engine to, for example, kind of like do the if you need to kind of like do aggregations, don't do them on the DL, do them or in this library, do them through SQL to DuckDB. So I'm trying to say is that at some point we might want to be clear that we are like a visualization library, but we are not going to end up being an embedded kind of like data engine. You know what I mean? And so I think it's more valuable that we think about like how we put, you know, like those other projects on the context of the vis.gl than instead of trying to build so much functionality inside. So I'm more of like, if we could make, you know, like loaders, DuckDB, Kala working together well now, so on, and people have the potential to Kala express in SQL using DuckDB, and all of that is Arrow and potentially Geo Arrow, so you can replace DuckDB if you want for something else. But if not, I think we might be in a better position. And if we traditionally done is like try to kind of like add more and more capabilities inside our ecosystem.
I think that's a really good. I mean, one of the things we would want to do if we kind of really adopt Arrow is obviously really make sure that we leverage the adoption of Arrow of the ecosystem. I think obviously there is a difference. You know, DuckDB offers all of these table transformations, but it does it on the CPU side. We would have the ability to create this GPU table and do things like that. But I mean, the initial, I think, focus shouldn't be to try to duplicate what, you know, DuckDB and other libraries can do on the CPU side, but maybe, you know, do things like we talked about before, like H3 projection on the GPU, or, you know, Mercator projection on the GPU, you know, float that to this kind of packing and so on, right? Like we would do those algorithms that we need to do for visualization, you know, but now we would move them from the CPU to the GPU, but would be a growing library of possible functions. And so, you know, we should invest wisely. But, you know, just to say there may be someone who just says, this is so cool, I'm going to go do, you know, a complete, you know, query implementation on GPU, you know, yeah, be able to stop them. But I think it's something we should agree with you. It's not something we should be pushing.
Yeah, I mean, as this whole geospatial stack gets more and more complex, then users have a choice about where they do a certain operation. Do you want to do filtering like on the GPU? Do you want to do it in JavaScript? Do you want to do it in your client side SQL implementation? Do you want to do it on server, the data warehouse? And you kind of want to do it at all stages in a way that makes sense. Ideally, when downloading a million rows and then filtering on the GPU, it's just going to be slowed down to like 10. And like ideally, we want to give the users the choice. And I think here, then the same way that it'd be good if GL was the project, it'd be nice. Sorry, if it was supporting and Arrow, it'd be nice if DB was supporting it as well, and we can do all these 0 copies.
And that actually also brings to me another kind of like important topic, which we have already covered in the vis.gl, but I don't think we're so explicit, is that there's these layers that are more kind of like document, like you have the entire data set in memory and you can operate with it like entirely in memory, or you have like child data sets. and there's different things that you can do with them. And this is important because, you know, like we know there's a point on amount of data that you're going to have to go to tiles, so you can transfer to a browser or something. So even if, you know, like Kyle managed to like load 100 million points, at some point it's going to be too much. So kind of like having that vision to the user of like, and that DGL can handle both sides. I work in one way and then move to the other one, that you're not going to have to change your layers, and that, you know, that I think is really powerful, because if you look at all the other libraries that are in they either kind of like take the decision very clearly. And I think, you know, because we were in Geo, we were forced ourselves to think around tile sets and things like that. And now we have a much more scalable framework than a lot of other frameworks that are out there.
I agree with that, and I think having really strong support for tiled approaches, and I know especially you guys at Kanto, you've been trying to extend support for layers into tiles. So you created like tiled heat map layers and a selection of layers. But I think it's the way we're doing it now is a very brute force approach. I think that there is potentially a very beautiful way to do this. And right now, what I'm talking about is that in the tile layer, the tile layer relies on a class called tileset 2D for the normal tile layer. It gets a viewport and it loads all the tiles that you need. Now that's very baked in to the tile layer, and it's very hard to use that one independently. But I imagine you know, a future version where we can use this tile set independently, tile set class, point it to a tile set, give it, you know, basically query region and maybe some other parameters. Then it automatically loads any missing tiles. So then on top of that, once you have all those tiles in there, instead of operating on the tiles as we do now and implementing again and again in a layer, what that would then do is it would because most of the time those tiles are just small tables, right? Each table, the vector tile contains a bunch, you know, it's a small table of relatively small table of geometries. What if we just merge all of those so that that tile set always has one table representing combined state for all the tiles that are currently loaded? Then all the table processing that we have will work on that. Every single layer that we've created for that just accepts a big table, which most of the layers do, and then work on any you know, on any tile set, and all the tile set class does, it just assembles the table, you know, corresponds to the current view. So I think that, you know, again, in the spirit of making things really composable, building on top of each other, and if we then make that so that this tile set not just creates like a GeoJSON table, but it does create an arrow table, you know, corresponds to, so that you know, combines with all these other things, and it could even be maintaining that arrow table on the GPU so that we don't constantly upload it.
So this would in effect remove
Tile layer could still exist, but at least I don't think we need to build 20 variants of it to duplicate every other layer, right? Yeah, maybe we could even do away with.
Something we discussed when we were talking about heat map layer, not working with tile layer, is what you really want to do is not a tile layer that contains multiple heat map layers. You want a heat map layer that consumes tile data, and maybe you don't even the heat map to be generated from scatter plots or paths. In a world where all layers can consume data tile, instead of having a tile layer that has a render sublayer function that renders a scatter plot from the data content, you'll just have a scatter plot layer data source that can retrieve data.
I mean, just as an example in the same kind of space, then built a layer that's like a cluster layer that is an extension of a tile layer, but it only renders one layer, which is a scatter plot. So it's basically doing this, but without any kind of official API that implementing it, and it works really nicely. So it's I think this idea is more just a matter of rearranging the code and building the abstractions and documenting it. Like, I think.
And it's not only tile layers. I mean, if you think about something like GeoParquet or some of these cloud native formats, it's not tiles, but it's kind of like loading the data in ranges. So it's kind of it's streaming, progressive load, whatever you call it. So there's these three ways, right? Load the entire data set, load it in ranges, if the cloud native supports it. Or
We're seeing more and more, exactly, we're seeing more and more formats like flat geobuf, right? Loader, you can apply it has a spatial index and you can give it a bounding box. And so, you only get what's in that bounding box. And as long as you don't zoom out, then get all data, but you stay on the right zoom level. So it works beautifully. And then, instead of just loading the entire data set once, you just wrap it in this little source class that I was talking about. Then every time, just the layer just tells this source that, give me the data for this viewpoint, the data for this viewpoint, it just reloads. And that can be extended to GeoArrow with the new spatial indexing. We saw that possible to load, data directly from hundreds of gigabytes using the spatial from the client using spatial indexing. We could even, top of this GeoArrow now, there's useful, movement where open table formats like Apache Iceberg are putting extra structure, and so you can deal with these collections really and query them in a standard way. And there's more and more, databases are implementing Iceberg compatible query engines. Why couldn't vis.gl have a query engine that would just be an Iceberg data source? So yeah, I think they're really, really exciting roadmap there.
So a question over here. Well, just wanted to support the idea of tile layers and loading in tiles as a concept, not just as a parent layer of other sublayers. We've done it with clusters in a very similar way that you were explaining, and I think it will be good to have it as like an API that is more like defined and supported and explained on the documentation. And maybe it could be a way where for any layer you can pass a tile layer as the child, so just flipping the hierarchy, something like that, to load the data, because it's very useful when you need all the data to do comparisons before the visualization. There's some room there for
that's exactly, and I've often found myself in the situation where wouldn't it be cool? I'm not even going to visualize it. I'm not even going to do, create a layer, but it'd be cool if there was an easy API for me to, just point to this tile set and just get the data covered by, and then under the hood, it would load the tiles. Because it's tiled, it would make sure that not too much data is loaded. It would assemble all that data, and then I can do any processing. So I could implement, non-visual functions. Right now, too much of the beautiful logic we have with assembling tiles and aggregating data is built into the rendering. Breaking that out and making it composable.
Yeah, like in the ecosystem I work in, I do a lot of animation, and one of the things that we kind of dreamed of is when you do have that kind of flip or that break apart is you could predefine a camera path that you want your map to go and view. And I'm sure interactive applications could have a similar thing. If you have a notion of where the user's about to go, if you could kind of predict the direction they're facing and kind of say, okay, I'm going to go and fetch that portion, not what I'm looking at right now, but what I'm about to look at, then it's another kind of powerful way it's a pattern that could become very powerful in lowering the latency there, but it could be really interesting for kind of animation applications where you don't want to be waiting around for stuff to cache.
It also feeds into widgets as well. You want to know what's the viewport, and then you can use it to populate some kind of data. Yeah. The graph, something like that. If it's currently locked away in the file layer, then you have to go through a callback or just duplicate that logic.
So you can't connect charts to it.
Question over here.
Yeah, so in the MapLibre community, people often ask about similar things to what we've seen here. like maybe new formats or sometimes also features that already exist in vis.gl. So question to you would be like, what's your wish for the future between MapLibre and vis.gl? Where should the two projects go? Where should we not overlap? Where should we work together? Stuff like that.
So I think at least like once every couple of months we had a question if we could use Mapbox/MapLibre style JSON with VT layer. And, I have personally been resisting that because I feel that there are libraries that doesn't more efficiently. That vis.gl should focus on high performance, dynamic, interactive visualization instead of drawing static maps, trying to repeat what someone else has already spent a lot of time investing in. I changed. I don't know.
Yeah, it's been a long-standing goal and strategy on that to always say, well, we're base map agnostic. The base maps do it great. We even provide interleaved renderings that you can share contexts. And I think to kind of get at the question that you're asking, where things should go is, at least today, I still love that that each project is still clearly got focuses on what they're very good at and are only getting deeper in that, and it kind of almost be a distraction or maybe unwise use of resources to try to duplicate stuff that's already being done really well, that we've already proven we're able to do interleaved rendering, we're proven we're able to do viewport interoperability pretty well. There are some rough edges, and maybe the focus should instead be on what those rough edges are. Like it would be great to have just more matrix sharing between like the viewports between libraries, and more clearly defined public APIs and how you're going to get like the projection matrix from one library for another.
Just got deep, right?
We did, yeah. But it took years, of that PR being open, and it's like I think it's just that was also just like a scratch of the surface of where we should go, because also now you look down the roadmap and the question of web GPU and interleaved rendering is going to come up at some point, right? And I don't think we've really started those discussions about how. This is a panel about the next 5 years, right? Like we're looking at the next year or two of web GPU adoption and this path of transition from GL to GPU. And we're in this position of we're going to be maybe potentially first to having GPU support, and it's going to happen before base maps. So what does that mean to all the people that are using base maps and are using interleaved rendering? I think that's kind of like an area of focus that I'm kind of curious about.
And I definitely agree about removing the rough edges. What we want to avoid is developers getting into a situation like, wow, I've been working with vis.gl, but there's this thing I really need to do and I can't do it here. I guess I have to go and do it in MapLibre. And then I'm going to have to re-implement my scatter plot layer there because I can't be using deck, and then kind of vice versa. So I think the stronger we can have like a collaboration, then this question of like someone saying to us, why can't I style my layer with style JSON? Like, MapLibre. If there's something stopping me, that's fixing it. So I don't know where we don't want to compete on base map rendering.
I think it's a good idea to collaborate more, but just for you, might move you a bit away from the paradigm of being base map render agnostic, right? If we say MapLibre is the main partner for base maps for vis.gl, that's great for MapLibre, but maybe that's not great for the deck users who want to use it with. Well, that's a question with what? Could be, of course, other renders.
I think it encourages the outside providers to work more with us if you work more with us.
Yeah.
Each base map integration mode has its own limitations, right?
Yeah.
Apple maps in the web doesn't even support tilting. The initial maps library did not have like free form tilting, and And during that collaboration, that conversation, like it really make it clear to the base map maintainers that this is something people really want. I think MapLibre right now is the de facto base map for all our examples because it is flexible, it is free, and we have really good collaboration channels open whenever we feel that we are just hacking away instead of secretly wishing for something. We could just go to the MapLibre repo and PR and get accepted, and that is super valuable to us.
And I strongly second that. I mean, my view is, I mean, the very notion that we would hold back on MapLibre integration because we were afraid of upsetting, you know, Mapbox or Google, to me is ridiculous. GL is a meritocracy, and you know, whoever comes in, and in terms of contribution. So if people come in and really collaborate with us, that is where we will put our attention. That's where we will, you know, what we will invest in. And you know, if we build a stronger partnership, even stronger partnership with Libre, you know, it might ruffle some feathers, but in the end, with better, you know, product. And I think, I mean, you can also see there's a little bit of existential angst in this, the question we posed here for this panel, right? How do we stay relevant for the next 5 years? And I think, you know, MapLibre is a very strong ecosystem, and vis.gl is a strong ecosystem. And if we get closer together, certainly, you know, vis.gl would benefit from. I hope that, you know, I have to say maybe more so than MapLibre would, but I think it would be good for both communities. And I see you, obviously, you have a very strong presence here today with, you know, met line with multiple of you, and you know, I think you've gotten a pretty strong sense of my personal wish, and that is that we would do a much deeper collaboration. And we've even had discussions, you know, planted some seeds about possibly, you know, shaving off a couple of years of your development time by reusing Luma.gl as the foundation for your web GPU, right? Which would be, if that happened, it would be deep integration. And we talked about the things that you're building, you know, around like text rendering, national languages and layouting of text. And if you could do those things the same way we do, usable models, it's benefit, you know, in all our text render, you know, tremendously. So there are things we provide value to each other. Not with that our basis of cluster. I'm not suggesting that we become one project. There's many reasons why, but I think we should be linked in a way that will share something.
If I may add also, because we did a lot of work also with integration and some of the map providers. I think it's not so much I don't think vis.gl has in any way kind of like a vision to compete with MapLibre in any way. Sometimes might be feeling the other way around, because, you know, there's a lot of stuff they can do with MapLibre so that you don't need vis.gl. But the vis.gl, at least the way that I see it, the vis.gl objectives will be that in every map provider, in MapLibre, Google Maps, Apple Maps, Mapbox, that eventually they have a vis.gl layer. And that's kind of like how they connect, you know, like the two worlds in a way. And then if it's advanced visualization with formats like this, vis.gl is the format. It is a de facto kind of like a standard as a library, and it works with all those providers, right? And it might also mean that we have to simplify also, like, for example, does it make sense that vis.gl has a Mapbox vector tile layer? It might confuse people because it feels like it might have some other problems that you like saying, you know, why cannot I style using the style JSON and Mapbox vector tile? Maybe we shouldn't have Mapbox vector tiles layers in vis.gl. And you know where I'm going. We cannot remove it immediately, but I mean, but as a conceptually, the idea is that vis.gl is kind of like data visualization on top of maps. In fact, it's even more than that. But you know, like, and if it's that case, I think it could clarify things more. So then, obviously, MapLibre has a very big interest in trying to make vis.gl work really, really well on MapLibre. So it is Google, so it's Apple, and so on. Which, by the way, we need them also to fund and to get developers to help us also on the vis.gl community. So, so I think that map agnostic, but you know, like clarifying where kind of like DeckGL wants to go and how it wants to operate with others, I think will be good. Just for the record, Google Maps has a DeckGL layer already in their documentation. I don't think MapLibre does. And that's kind of curious.
Does have an DeckGL example.
The MapLibre has already one?
Yeah.
Okay.
Maybe not in the documentation part.
It's there.
Okay, I will check about it and see.
It's pretty clear, you know, the course of today, you see where our development interests and priorities are. We want DeckGL to remain the, you know, state of the art visualization library by really prioritizing high performance, large amount of data loading, being able to provide the developers the flexibility to some of their layers from their data, and, you know, making yet another base map renderer is not one of our interests.
I fully support the idea of base map agnostic DeckGL and focusing on the integrations. And then for the next 5 years, my question comes to the globe integrations, which I understand is going to be a large can of worms, right?
Integration?
Globes, Mapbox globe and MapLibre globe, the globe view basically.
Globe projection.
Yeah, globe projection. It's not that easy as Mercator.
Area where if we collaborate with a provider.
MapLibre just had a globe something.
It's not merged, it's in the final stages, the branch, yeah.
Let's say we want day zero integration with MapLibre's globe. I don't know if we can, but give it another try.
Take it for a spin, let us know where we are.
DeckGL has an experimental globe mode. We are very careful about not looking at Mapbox code because it's license. We are even welcomed to look at how MapLibre implemented it, and you know, in terms of common space sizing. For example, we could design our projection in the shader exactly the same way MapLibre is doing it, and it's just a matter of
Yeah, I actually think this is a great example of like where the collaboration works for both sides, because to implement a globe mode is not just like the rendering side of things. It's also like the controls, the kind of the feel of the whole thing. And for us, if we can basically share the viewport and make sure that our layers can understand the same kind of transformations, we get all of that user interface that someone like Libre has built free. Like we really don't want to have to re-implement all of that on the DeckGL side. But if we can render it in the same way, then that's perfect.
But that's another example of where we have to be careful in our examples. Because if you look in DeckGL examples, there's a globe view. Now you get like users asking like, well, should I use the DeckGL globe or should I use the MapLibre globe with DeckGL? You see, so that's a case where
the answer is you can use both.
no, I actually think that we should be more active in there. If we have like a good, you know, like implementation of a globe with MapLibre, I would suggest that we remove our globe view.
That's
Well,
a bit the thing.
We do need a globe view so we can have a mode that works with the MapLibre globe. Right?
Yeah, but I'm just trying to kind of not confuse the users towards if they have to choose between DeckGL and a map base and a base map provider.
Part of it is part of being base map agnostic is you can also use without a base map.
Right. Not with a globe. Maybe.
I think talked so much about geospatial, but the MVT layer was brought up today, and I remember back to the history of why we ended up resisted for years to add an MVT layer. I remember why we did it. I remember it was a non-geospatial use case that ultimately, I believe, motivated the inclusion of it. You know, there was something in the biology space, I remember. And it's just to say, DEC isn't only a geospatial data visualization library. I think that it's actually maybe still an open question on like, is it just a geospatial one or not? And how much kind of focus should we have outside of geospatial and for the things that are in there and are motivated by non-geospatial use cases, you know, what should we do about them in the next 5 years? Are really relevant outside of the geospatial use case? You know, if so, it kind of implies where we should continue to put energy.
I think what WebLibre could do is to redirect users or requests sometimes to DeckGL. Because, for example, we have people asking for 3D tiles. And now today I saw you can render 3D tiles, right? So why should we have that in WebLibre, really? Or things like that. Oh, you don't, but it would be a big engineering effort to have it, right? So maybe in the future, things like this, we could say, like, for some things, we just tell our users, please use DeckGL on top of LibreBase. But you know, like, just because sometimes people come and they, you know, that like people they don't know what a tile is, but they want to have something on a map. So, and for this sort of knowledge level, I think it's good if we have a common way of like saying, like, this is the responsibility of WebLibre, not the base map, and this is responsible.
Yeah, the 3D tile is also another interesting because we have a pretty good implementation. One of the weakest parts is the controls don't take into account the aspects. So you're looking at like a mountain, and it does something really weird. 1,000 meters. So here it's just the difference between the coders doing like the controlling as well, the render. And for the idea for us, like in this case, if I jump to a different library, perhaps then they've shipped 3D tiles in their code base. We don't yet have a way of integrating with this, but they have a beautiful way of controlling the camera space. So what we would ideally want is just to be able to be told, okay, what's the height? We can put all of our objects in there. We can add some scatter layer, line layer, not have to worry about implementing a camera that understands what a 3D building mountain. I think this is also a conversation that we'd have to have if you want to integrate 3D tiles in WebLibre. Well, who's going to be responsible for the camera? It's all of a sudden going to put a 3D mountain into your view. WebLibre doesn't know about it. It's controlling the camera. Then how do we integrate these?
There is more sophisticated implementation in WebLibre than DeckGL terrain.
Yeah, and I remember when we went, especially to React Map 7, and that transition, it felt all of a sudden very comfortable to, once we fully delegated control and ownership of certain things to the base map library. Because now there was no longer this like bi-directional sync. And so it becomes the conversations around like Deck is like in a very comfortable position to render into something that has been delegated to it. And so if in the case of the globe projection, I see that as an instance where, okay, WebLibre defines what the globe is, and then it can delegate what those parameters are down, and then Deck can render on. And so it's very unidirectional there, very smooth. When it's like it becomes this interesting conversation and possibly a very valuable one again, with the 3D tiles case, because now you're saying, oh, actually, we want to do a bidirectional sync here because the engineering effort involved of, you know, rendering that upstream in Libre and then actually drawing Deck onto a 3D tile is not the direction we want to go in this instance. But now that all of a sudden means now you have to do some syncing upstream about what Deck is actually rendering, so that WebLibre can be aware of that, not only for camera but for occlusion too, right? I mean, not just depth occlusion, but I mean like text offset, street offset. You know, how the elements that you're painting on the screen, you'd probably want to drape that potentially so that your 3D tiles don't just completely occlude the vector elements that is drawing. So it kind of you know, we closed the can of worms on controls in a sense with the transition to 7 on React Map GL, and this would kind of be opening it again for a different purpose, where now it's about doing some kind of render syncing, more complex like 3D frame buffer, I don't know, syncing. So it's just interesting. I don't really have an answer, but it's just kind of an interesting evolution question there.
Besides camera control, there is also the question of who handles the mouse events, right?
Right, and then now when you use,
Do it both ways.
you could do it both ways. And we've made a harder cutoff on like you do it one way and you get fully delegated to map library for that, or you do it the deck way and it's fully the deck way. You're not really going to be mixing the two, because back when we would do that, it just caused all kinds of problems.
But right now it's like completely two separate implementations, and it's not easily switchable. Right?
It's easily switchable. It's not usually mergeable.
The difficulty is that different base maps expect like different ones. Sometimes they want to be in control. Other times they don't give you any callbacks, but they accept keep state. They'll have to implement both to largest compatibility.
That time, basically. We have another session tomorrow, another day tomorrow full of application-focused talks. Today you heard a ton about the ecosystem roadmap. We talked about the next 5 years, and you could definitely get a sense of where people are headed, where their heads are at. Tomorrow will be a lot more focused on power users, end users, users that are building applications with this ecosystem and doing really interesting things there. And so it'll be a bit of a shift in mindset, but a really interesting one. And we'll end that day tomorrow with another panel that's more focused on how we can be more empowering to application developers too. So thank you so much for coming for today. Hope you had a good time.